Solving this integral using the third integral representation for digamma function. So this integral over here is what I consider the third representation. So basically there is no such name as third or second. And if you want derivation of this integral representation for digamma function, you can check a link over here. Okay. So now we have this. Let's begin solving the problem. So first thing we do is try to change the cot x in terms of e. Yeah. So we have integral from 0 to infinity e to the power minus ax and 1 by x minus. Now this is basically e to the power x plus e to the power minus x by e to the power x minus e to the power minus x. Yeah. So basically, since we want these negative powers, what we can do is divide by e to the power x. Yeah. And that gives us 1 plus e to the power minus 2x by 1 minus e to the power minus 2x. And this definition is what we will use. So we have 1 plus e to the power minus 2x, yeah, by 1 minus e to the power minus 2x dx. Now basically over here I need just minus t. Yeah, so that's why what I can do is I can let t equals to 2x. So if I do that substitution, I get dt equals to 2 times dx. The limits remains unchanged. Over here I now have minus a by 2t. Over here I have 2 by t minus over here 1 plus e to the power minus y by 1 minus e to the power minus y, and dx is dt by 2. Now I multiply by 2, multiply 1 by 2. That gives us integral from 0 to infinity e to the power minus a by 2 t. This is 1 by t minus this, and then the other thing is 1 by 2. Okay, and now, okay, so basically let me write it as it is for now, and then I will tell you what I going to do next. Okay, so next thing I'm gonna do is, so basically I'm gonna write this as 1 minus e to the power y plus 2 times e to the power minus y, cause this will simplify the stuffs, because in the next term there's no such thing as constant terms, and over here this is cancelled out. So that's a better approach, and then we will later see like how do we deal with the problem later on, but for now that seems to be a good thing to do. Yeah, 1 minus e to the power minus y plus e to the power plus 2 times e to the power minus y by 1 minus e to the power minus y, yeah, and then dt. Okay, now what should be our next approach? Let's see like how this goes on, and we will decide our approach. Yeah, 1 by t. Now this is just minus 1 by 2, and then we have minus, and then what do we have? So we basically have this 2 cancels out, so e to the power minus y by 1 minus e to the power minus y. Okay, so how is that we have y over here and t over there? How did I write y? This is actually t, because I made substitution with t. This is such a silly thing to do. You might have been wondering all this time like, why am I writing y? Basically the reason is when I read in my copy, like I made y substitution, so now when I'm doing over here, like my mind was just there sort of and that's why. Okay, anyways, it's fine, you should have understood it. Yeah, and even if you did not, now at this point you might have understood it. Okay, now after this we'll just multiply these stuffs. So with the constant it will be easier to integrate. Minus 1 by 2 e to the power minus a by 2 t. Now other thing might be somehow complicated. E to the power minus a by 2 by t. Yeah, and then minus over here e to the power minus t a by 2 plus 1, yeah, by 1 minus e to the power minus t dt. Now for the formula of digamma function, we don't have anything such as anything constant over anything other than e to the power minus t, yeah. So now let me make a new formula which is slight modification of digamma function. So what do we do when we have such cases, such as when we have e to the power minus at by t minus e to the power minus xt by 1 minus e to the power minus t. Now what to do in such cases, because we don't have that thing over here. Now in such cases what we can do is we can just subtract and add that term. Okay, now after this step what we can do is this thing over here is just the Furlan's integral. Okay, if you don't know what Furlan's integral, I'll attach a video over here, you can watch that. Minus e to the power minus t by t plus this over here, it will be e to the power minus t minus e to the power minus xt. This is by t, this is 1 minus e to the power minus t dt. Now this thing over here from the Furlan's integral, it's just minus log of the first thing, and if there are something we will just write over there by 1, yeah. So this is what Furlan's integral says. And if you want the derivation of this also, let me do it over here. And this is a different version than what I did in the video. So basically, if you have e to the power minus at minus e to the power minus bt by t, what we can do is we can basically take the Laplace transform of the numerator, yeah, and Laplace inverse transform of, basically let me write the whole thing, this will just be confusing. Okay, so when the integral is from 0 to infinity and there are two terms, we can take the Laplace transform of one term and the Laplace inverse transform of other term. That's allowed by Maths identity. Yeah. Now the Laplace inverse of 1 by t is just 1, and the Laplace of this thing is just 1 by s plus a minus 1 by s plus b. And this is just 1 ds. Now this is easy, yeah. Now this is just ln of s plus a by s plus b going from 0 to infinity. At infinity this is just 1, so ln of 1 minus at 0, this is just ln a by b. So you basically get minus ln of a by b, yeah. So this is a whole new proof of Furlan's integral. Now so we have minus log of a by 1, yeah, over here there's 1 only. So and now this is just digamma of x, yeah. So basically in such cases, if there's at, what we have is minus log of a plus digamma of x, yeah. So that is the thing. And now let's solve this integral. So for this, like, can you guess what will be the answer? Now for the first one, it's easy because that's just e to the power minus a by 2 t by minus a by 2 from 0 to infinity. Minus sign cancels out, 2 cancels out. And for this one, that will be, we just discussed, that will be, I forgot, wait a second, minus log a by 2 plus digamma of a by 2 plus 1, yeah, and then plus c. Now from here we have this is 0 minus 1 by a, and now from here we have minus log a by 2, and then from here we have digamma of okay, now we need another property. Digamma of x plus 1 is just 1 by x plus digamma of x. That's why we have 1 by 2 by a, sorry, a by 2, not 2 by a, 1 by a by 2 plus digamma of a by 2. Okay, not plus because this is a definite integral, I'm sorry for that. Now after this, this is 2 by a. 2 by a minus 1 by a is just 1 by a minus log of a by 2 plus digamma of a by 2, and that is a perfect answer. Yeah, and digamma a by 2 can be found out easily. Yeah, basically, since we don't know a, like we don't know digamma a by 2 for now, but that's not a hard thing to deal with. And minus log a by 2 is also can be also found, and 1 by a is a good thing. So the answer is, let me write it over here, 1 by a minus log a by 2 plus digamma a by 2. Yeah, is that? Yeah, hope you enjoyed the solution. The solution development involved definition of cot x, and then we made a substitution, uh, and then it was just this was just the definition of the gamma function, somewhat modified by the full Lorentz integral, and then it was solved. So this was basically not a hard integral, and hope you enjoyed this solution. Thanks for watching. Look forward to seeing in the upcoming videos too.